Alright, this is a demo on loading up a piece on the B Mill. So first thing we want to do is open up the file we want to use. In this case, it's this design here. We are going to make sure that the ortho is turned on and the grid snap is turned on. Because the first thing we need to do for the B Mill is to create supports. So we'll go into the solid section and we're going to select a box. We'll go down into this through finger view and I'll actually expand that. Usually I'll make the box about 2 millimeters tall and I'll bring it all the way out, you notice, right to the edge of that grid. So I'll click there and then I'll usually make it about 2 millimeters wide as well. So we'll click there as well. So there's our little box. But if you look, it's not centered with the ring, so we're going to just take that and just drag it down until it's centered. Since the grid snap is on, it's easy to do that. So if you look in this, it's centered this way, it's centered that way. So we'll take that, and then the next thing we'll do is we'll go into the Transforms tab and hit Polar Array. Now it's going to ask up here the center of polar array. We want it to be right there at the center, or you can hit F4 and that'll be the center. Now it's asking you the number of items you want. We're going to want 4. Hit enter. And then it's going to ask for the angle to fill. The default is 360 and that's what we want. So we don't touch anything, we just hit enter. And then it's asking you if this is what you want, and it looks good, so you hit enter again. So we've got those 3. Now if you look in here, this ring has a cutout area, but this support goes through that. So what we want to do on this one is we want to do a one-dimensional scale. We're going to grab it there and grab it there, and we just want to scale it up so that that section is not in that cutout area, because when it cuts, it's going to see that and it's going to cut that support as part of the ring. So we've got our 4 supports. The first thing we want to do is grab all 4 of them, hold down Shift, and hit F2 or group. So now all of those are grouped as well as the ring is grouped. So now we want to go up into the Builders tab, which is the bottom one on the left. Click Builder, and since we're doing this for the B Mill, we're going to select this Toolpath Builder. This is for the B, this one's for the C. That one's got a little C on there, this is for the B. So we'll click that, and it's going to open up on the left-hand screen the B lay, the builder. So the first thing we want to do, since this is a ring and it's on a rotary, we're going to go down here until we find the one that says Auto Flip plus Rotary 3 operations. We're going to click on that, and then we're going to click the Advanced Options. Click on that as well. We're going to select our ring and we're going to put it in the model box right there. What that's going to do is automatically read the finger ring size as a 7. We want to make sure that that reads that. And then we're going to need to select a fixture plate size. So we'll select the little arrow, and for the most case you're going to select the 50 millimeter plate. So we'll select that. You can see in this view it's got the plate selected. We'll go over here, hit next. Now on the core, usually I build the number of inner supports as 6. So I'll hit 6, and the center core size will depend on the thickness of the ring. Now this ring is a little bit wider than 5 millimeters, so on this one we're going to select probably 5 and hit create. Now if the ring is a little bit wider, I would use and you can see here it actually defaulted back to 3, so we're going to go down here and hit 6 and hit create. So now it's got 6. You can see before, that's what 3 looks like. Sometimes you want to use 3 if you want, but I always use 6 just so that it has lots of support. While it's still selected and still purple, we're going to hit Enter. Okay. And since these are all grouped, we did earlier, we just select those and we'll set those into outer. So we'll put those into the outer and those are the inner. And again, this core size, depending on the width of the ring, you're going to want to adjust that a little bit. If the ring is a little wider, I would go maybe 6, 7, maybe all the way up to 8. I wouldn't go any more than 8 millimeters wide on the center core. But I've gone from 4 to 8. And as I mentioned earlier, if the ring is extra wide and you need a little bit more support to hold it in place, you can grab these inner supports here, and if you hit Control C, that'll copy it, and then hit Control V, and that'll paste it in place. So then you can see there's 2 of them there now. You can take one of them and you can just kind of drag it out a little bit, give it a little bit more, and then hit Control V again, you paste another one and drag it the other way. So if you need a little bit more extra support, you can see how that it gives it a little bit wider. In this case we won't do it, but sometimes you will, and then again you want to grab all of those and select and put it into the inner core. On this one we won't, but on those you do. Just hit those and delete it. But just remember, if you got an extra wide ring that's 10 millimeters, 15 millimeters, you want to add a little bit extra support. Otherwise your ring, portions of it might break off because it doesn't have as much inner support. So we've got all that selected. We go to Next, and this opens up the STL options. You want to go down here where it says maximum distance edge to surface, and the default is 0.01. You want to make that, just double click on there so that your cursor is blinking and make it 0.001. You hit Enter and then hit Create STL. And that takes not very long, according to how complex the model is. Let's go back here just to make sure. Okay. Okay, and I hit Create STL. Okay. Just want to make sure that you've got your plug, your inner supports, and your ring and your outer supports is all there. So then we hit Next. The first button is your cutout supports. That's automatic. You don't change anything. The second button is your flat milling options. The first thing you want to do is open up your mill depth. We'll zoom out here a little bit just so you can see what's going on. Click on this yellow box here. That's going to set your toolpath depth. You can see in this view, side 1, and you just want to make sure that it's going past the center line of the ring. This one looks good, so we're just, while it's still selected, you're just going to want to insert it into that box. Open up your custom borders and select on the little yellow button next to the custom borders box. Click on that, and what you want to do is you build or draw a bounding box around your design, and you want it to be between 1.5 and 2 millimeters outside of your design. So just kind of zoom in here and look and say there's 0.5 millimeter, 1.5. So kind of somewhere along there. So just drag that over until it's kind of along the same lines as on the side here. Just kind of eyeball it. 1.5 here, 1.5 there. Click, and then you'll drag this, and you want to usually make it symmetrical. So So if the distance you got here, you want to keep that same distance there. And click. So you can see there's about between 1.5 millimeters and 2 millimeters there. The same here, the same there, and the same there. So we take this and insert it into the border. And that's all set. You don't do anything with these two tabs there. Go up here and select the second flat milling options and do the same thing. Click on this yellow box. That's going to give you your cutter. You can see, and just make sure that it's cutting past the center line. Insert that into the depth box. The second one is the custom borders. We've already drawn this, so just select that and insert that into there. So those are done. Go to the Rotary Three-Sided Auto. And the only thing we'll change there is here where it says the default is the 0.05. We're going to change that to 0.03 on both of these boxes. Just double click and see where it's blinking. Backspace 3, hit enter. And then go up to here where it says make paths. Click on that. And don't click on anything else, just wait for it to finish doing its toolpath generation. Again, on simpler models it goes pretty quick. On complex models it might take a little bit longer, but just let it do its thing, and it will get there. While it's building it, you can move the mouse around, but don't click on anything, because if you click on anything it'll interrupt the toolpath generation, and it might either crash or give you an incomplete toolpath, and then you'll have to start all over. You can see over here it's giving you a percentage of how much time is left versus how much is completed, and just kind of be patient with that. And it's just about finished, and you'll know when it's finished when all 4 of these boxes are green. And there we go. And then you can see how it's red. That's your toolpath. And I mentioned before, we zoom in and you can actually see the toolpath. So we will go over here to where it says make RVO. Click on that green box there. Click on desktop. And then you name your file. The name of this is a WG. And you can see it automatically fills. So we'll backspace until we get to there. It's a WG, it's a special order, size 7. You want to hit 2 side flip plus rotary and 10 millimeter. What that does is it gives you the style name. This is a WGFR50BL-SP-7. The 7 is the size. This is a size 7. The next thing is a 2-sided flip plus rotary. That's the operation that it's going to be cutting. And the last thing is a 10 millimeter. Remember when we looked at the ring earlier, it was right at 5 millimeters wide. And since it's that close, we just want to make sure that it doesn't have an incomplete cut on the sides, so we'll use a 10 millimeter. So if the ring is in between 0 and 4.5 millimeters wide, we use a 5 millimeter wax. Anything from 5 millimeters to 9.5 millimeters wide, we would use a 10 millimeter wax. And anything from 10 to 14.5 millimeters wide, we use a 15 millimeter. So you want to give yourself just a little bit of leeway. Make sure that's on the desktop. Hit save. It doesn't take long to save at all. That's done. And if you want to, you can click on this little box right here. That'll give you the estimated time. it gives you 2 times. The first one is for a Model A mill. That's not the one we have. We have a Model B mill. So if you look where it says Model B, and it gives you an estimated 1 hour 49 minutes. So that's about how long it's going to take to mill that out. So we're done here. The next thing we'll do is, you don't want to click there and close out, because that'll close out the whole program. You just want to go up here and click the little X. And there we go. And F9. And you want to save it, but you want to make sure that you're saving onto the correct file name, because sometimes that will default to where it just says Revo model. You don't want to do that. You want to make sure that this says the style of the piece that you're working on. So in this case it does, but on half the cases it won't. Especially if you're doing a C mill, then it's going to automatically default to a Revo model. But in this case it's the right model, so you just go up to hit save, and we're done. When you go to your desktop, this is the folder or the file that we have. If you click in your flash drive, it'll open up a box. You just take this and you right click and drag it into the box, or into the flash drive folder, and hit move here. And what that will do is it'll move from your desktop onto your flash drive. And then you do the same thing when you get to the mill. You move it from the flash drive onto the desktop of the mill by right clicking, not left clicking, because if you left click it's going to duplicate it, but if you right click it'll actually move it and delete it off your desktop. So that is the B mill demonstration.